Okay, third installment. This is problems 21 through 30. However, we're going to skip number 21. So going on to number 22. Two children set up a lemonade stand in their front yard. They charge $1 for every cup. They sell a total of 15 cups of lemonade. The amount of money the children earned, R dollars, is a function of the number of cups of lemonade they sold in. In other words, R of N. Okay. Part A is 20, part of the domain of this function. Remember, the domain is the independent variable, which is right there, so that's N. That's the number of cups of lemonade they sold. So it says they sell a total of 15 cups. So it is not, 20 is not part of the domain. Because only 15 were sold. What does the range of the function represent? It represents the money earned selling the cups of lemonade. The set of values in the range of R, okay, if they sold 0 cups, they made $0. They can't make negative dollars. Also, they charged $1 for every cup, so they couldn't make $1.50. So, whole numbers from 0 to 15. We're not going to talk about D. Number 23 says, here are rules that define function f. These right here are all of the y's for these x's. So, for example, this first one, this first function says y is 2 if x is from -5 to 1. So here is y is 2, and it's from -5 to +1, and the circles on the ends are solid because, and the line is solid because it's or equal to. Then this next one says y equals x if x is 1 to 5. So what this one's saying is y is the same thing as x. So if x is 1, so is y. If x is 2, so is y. So if x is 1, so is y, but it's an open circle because it's just less than. And then all the way to 5, if x is 5, so is y. It's an open circle. And it's all of those. And then the last one says y is 7 from 5 to 7. So the circle, the end point is colored in since it says or equal to. Okay. So the domain of a graph, number 24 says, describe the domain and range of the function this graph represents. The domain of a graph is the start to finish, right to left. So it starts at -5 and it goes all the way to 10, but there's not a point on 6 or on -3. So all of the x's are used from -5 to 10 except -3 and 6. So the domain is all numbers from -5 to 10 except -3 and 6. Now, the range is start to finish, bottom to top. So -2 is the lowest it goes. Even though this point right here is open, these points here have -2. So -2 is still used, just not for that point. Same with this 4 up here. So it's all numbers from -2 to 4. Number 25 says the parking rate R for a car in a garage is a function of T, the hours it represents. So this is the rate for 1 hour. The rate for 1 hour says it's free. From 0 to 2 hours is free. So R of 1 equals 0. This says, the next one, B, says the rate for 4.5 hours. So 4.5 hours is in this range. It costs $6. So R of 4.5 equals 6. And then C says R of 8. Well, 8's not listed, but this right here says anything greater than 7, which 8 is greater than 7, is $8. So R of 8 equals 8. (26) says each equation defines a function. Write an equation for the inverse of the inverse function. So for part A, it's solve for y of x. The inverse is solve for x. So I'm going to subtract 65 first. The 65s are gone from the right. On the left, we have y of x minus 65 equals 5x. Now I have to divide everything by 5. 5s are gone on the right. So my function is, or inverse is y of x minus 65 divided by 5 equals x. For B, the function is f of t. The inverse is going to be solved for t, have the t by itself. So I'm going to get rid of that 3.5 first by subtracting 3.5 from both sides. So I have f of t minus 3.5 equals negative 0.5t. Then divide both sides by negative 0.5. So f of t minus 3.5 divided by negative 0.5 is what the inverse equals, t equals. And then C, P of n equals n divided by 3 minus 1.2. So the n is going to be by itself this time. The n is the only thing being divided by 3, so I'm going to add 1.2 first. So I have P of n plus 1.2 equals n divided by 3. Now I need to get rid of that 3. It's being divided, so I'm going to multiply both sides of the equation by 3. So I can leave it like this. 3 times P of n plus 1.2 equals n. And we're skipping number 27. 28. This is Unit 5. A bond is initially bought for $250. It doubles in value every decade. Complete the table. So, decades since the bond is bought. 0 decades means that's when it started. It started at $250. Then it doubled every decade. So, 250 times 2, 500 times 2, 1,000 times 2. So, multiplying by 2 each time is using an exponent, but we have to give our starting amount. So it says, how many decades does it take before the bond is worth more than $10,000? Well, after decade 3, it's worth $2,000. Decade 4 doubles again, so it's $4,000. Decade 5 doubles again, so it's $8,000. Decade 6 doubles again, so it's $16,000. So it doubles between 5 and 6 decades. So it takes between 5 and 6 decades to reach more than $10,000. Write an equation relating V to the number of decades. So the value of the bond is the starting amount, which is 250. It's doubling each decade. So the D is in the exponent position. $29. A piece of paper is folded into thirds multiple times. The area A of the piece of paper in square inches after n folds is A equals 90 times 1/3 to the n. What is the value of A when n equals 0? So when n equals 0, A equals 90. This represents the starting area. Okay. B says, how many folds are needed before the area is less than 1 square inch? So I'm just going to randomly pick a number for the folds. Let's say 4 folds. So for B, I'm going to take out the n and replace it with 4. So A equals 90 times 1/3 to the 4. That represents 4 folds. Whenever I type that into my calculator, I get the area is about 1.1 inches squared. So now I'm going to do for 5 folds. A equals 90 times 1/3 to the 5th. Type it in my calculator and I get that A is about 0.4 square inches. So it takes 5 folds Now it has to be 5 folds because you can't fold it 4.5 times. 4 folds didn't make it small enough. You would have to fold it 5 times for it to be less than 1 square inch. C says the area of another piece of paper in square inches after n folds is given by B equals 100 times 1/2 to the n. What do the numbers 100 and half mean in this situation? So for part C, 100 is the starting area of the paper. And 1/2 represents folding the paper in half each time. Number 30 says the population P of migrating butterflies satisfies the equation P equals 100,000 times 4/5 to the W, where W is the number of weeks. Complete the table. So when W equals 0, that's what the migration starts at, and it's 100,000 butterflies. At the end of the first week, there are 80,000. Then the next week, 64,000. The next week, 51,200. Fourth week, 40,960. Okay. W is the independent variable, so weeks goes across the x-axis, and that means the population goes up the y-axis, and I'm going to put that in thousands. So I'm going to count the weeks by 1. And I'm going to count the population like this. 0 week was 100. After week 1 it was 80,000, then 64,000. Then week 3 it was 51,000. And week 4 it was 40,900. And so this is an exponential function. The vertical intercept of the graph, that's the same as the y-intercept. It is 0, 100,000. And that is the starting population. About when does the population reach 50,000? Well, at week 3 it was 51,000, and at week 4 it was 40,000. So sometime in that area between weeks 3 and 4 is when it reached 50,000, closer to week 3. So I'm going to say shortly after week 3. It reached 50,000.